The ecosystem is set up for you to fail safely. Are you willing to accept that failure? So Shashwat and I spent about a year just figuring out what to build. You also need support from your PhD guide. The PhD guide can make or break your career. That creates a question. Why are all silicon making companies that large?
Hi, my name is Amrit. We've heard that IT Madras is the best place to build. So we've come down to the Sudhan Shankar Innovation Hub. We want to meet some people. These are builders. We want to talk to them about their work and also ask them what makes IT Madras the best place to build. Hi, welcome to the Best Place to Build podcast. I'm sitting with Sharan. Sharan is the CTO of one of the hottest new startups from IT Madras called Mindgrove. They're in the semiconductor space, and we learn from him what he does and about the semiconductor space and about the build culture at IT Madras. He's at the center of it all. Hi, Sharan, welcome.
Thank you for having me here. It's a pleasure to come back to this space.
Yeah. Firstly, congratulations on your funding announcement. It's a big deal, and earlier this year you got the DLI nod also. Can you talk to us about your funding announcement?
Sure. We are actually quite grateful that we've had almost every investor who invested in us in the previous round doubling down on us. We take that as a sign that we are moving in the right direction and we are trying to do the right thing. And then as a vote of confidence. In addition, we have two new investors, Rocketship VC and Mela Ventures, who will be joining the cap table of Mindgrove Technologies after our Series A round. And we have raised a total of about $8 million US, and that's the capital we have to take things forward. We took our seed round with the pitch that we wanted to make a chip. Now the pitch is we want to keep making more chips and we want to sell the ones that we have actually made. So that $8 million in order to get around to do that. And we additionally have been approved for the DLI scheme, or the design linked incentive scheme that is offered by the government of India. This is approximately $2 million INR 15 crores worth of incentives if you meet certain milestones, and we have been quite thankfully approved for that. So quite chuffed, but looking forward to the challenges that are almost certainly going to come at us in the process of doing this.
And you also have some really good quality VCs. Rocketship, of course, ITM alumnus themselves. There's Peak 15, there's Speciale being an investor who has repeatedly invested in IIT Madras based hard tech startups. That's amazing. Yeah, and these are brave investors because some of these will require 10 years. These companies, maybe not 10, but maybe, to sort of pay back.
Oh yeah.
Also, especially in semiconductor space, globally there have been very few startups. Like traditionally, none in India, or very whatever have come out now, maybe in the last 10 years.
Well, I would not say that there have been none in India. There have been some startups in India in the previous generation. It is just that due to the nature of capital and expenditure that is involved,
Right.
most of these startups, that the previous generation of startups, either had to exit by selling themselves to a larger company, becoming a subsidiary, or getting absorbed by a larger company, or they've had to incorporate in places like the United States, where funding was much more prevalent. We're talking 28 to 2012, 2013 kind of era. So it is not that there have not been startups, there have been more there, but life was, relatively speaking, life is easier now than it was 10 years ago from a funding aspect, because venture capital itself in inside India has evolved that much more compared to 15 years ago.
Understood. Can you tell us what your products are about? But before that, can you give us an overview of the semiconductor space? Right. I think the government is doing a major semiconductor push, and we've all collectively learned a huge number of new words. SOC, SOM, and MM nanometer, I guess. and all these terms. So just a fab, foundry, OTMP,
ATMP.
ATMP, OSAT. Can you give us a overview of what these terms are? Where are you placed in this ecosystem?
That will turn into a lecture.
Let's keep it very, very simple.
Sure. So the semiconductor industry is one of the most fundamental industries in existence today. Why? Because most of the things we do has become digital. And if you need the word digital, you need the semiconductor industry. It is what makes digital happen. You want a cloud? You need semiconductors to get server grade chips. You need semiconductors to get server grade storage systems. Your Google Drive or your OneDrive of the Microsoft cloud, same thing. You write software that is hosted on AWS. You need server grade chips. You are, that dabba that you take the QR code to make UPI payment. That dabba that says you have paid so much rupees. The sound box. Dabba sounds better,
Oh, okay, sure.
It sounds more fun. Sound box is so
Yeah,
very formal.
yeah,
So that thing has a semiconductor chip in it.
right.
The process of you taking a QR code requires a phone, which is one of the flagship items of the semiconductor world today. So it's everywhere. Our switches are no longer mechanical. We have buttons that we press, or we have touch screens where we click at a certain point of the screen to increase or decrease fan rates. So all these things require chips. All these things require what are called passive components like resistors and capacitors and all of that. And the underpinning of all of that is semiconductors. So what is the semiconductor industry? Everything is the semiconductor industry. Because even for cooking these days, we use induction stoves.
Right.
And induction stoves have electronic components in them. And electrical power components in them, which are also semiconductors. If you plug it or you run it by a battery, it has semiconductors in there.
Yeah.
So it's a very wide thing.
What part of this business are you running?
Mindgrove Technologies is what is called a fabless design company. So we are a pure play design house in that we do not do manufacturing by ourselves. We design a lot of stuff. What we do there is that we design a chip, have it manufactured elsewhere, have it tested elsewhere, and then we take it and we sell the chip. So it is only the design and the selling part that we work on. Manufacturing is typically outsourced to other people.
Okay. So Qualcomm and NVIDIA are also fabulous, right? They also design and
Yes.
somebody else manufactures.
Qualcomm and NVIDIA are very classic examples of fabless semiconductor entities. A clear example of somebody who does design and also does manufacturing in-house would be Intel, who make their i3, i5, i7 chips, who design it themselves and manufacture it in their own fabrication plants, and to an extent Samsung.
I guess Samsung is also like, when you look at Samsung as a company, it does phones, washing machines, fridges, like it's just so many things, right?
Yep.
Like I'm guessing that some of it they do themselves and
Absolutely. So Samsung, to the best of my knowledge today, Samsung is the largest manufacturer of memory chips in the world. There's quite a lot of competition going on. Samsung, Micron, SK Hynix, and so on. But as far as my recent most knowledge is concerned, and feel free to correct me if I'm wrong, Samsung is the market leader in the number of memory chips that are being sold.
Right.
So they do make it by themselves. They make other components like image sensors and stuff like that by themselves. Do they exclusively make all the components that go into their phones? I don't really know. So they're for consumer electronic components, but they do make a lot of their own stuff.
Fine. So there are companies like Samsung and Intel which design and manufacture. Then there are companies like NVIDIA, Qualcomm, and Mindgrove which design but don't manufacture.
Yeah.
I'm guessing there are companies which manufacture but don't design.
TSMC is a classic example of that. We don't care what you build. We don't care what you design. We will manufacture it and give it to you. What they are called pure play foundries.
Right.
Because the only thing that they do is manufacturing.
Right.
So their job is to take a piece of silicon that's like this, a circular piece like this.
Is it this big?
No, it's not.
Okay.
It's only about 12 inches in diameter.
Okay.
So it'll be about as big as a typical plate.
Yeah, so the size of this iPad.
Yeah, pretty much. 12-inch circle with of a 12-inch diameter. And what they do is they use lasers to etch transistors and circuits onto that silicon. So they will literally, it's like taking a knife onto this wooden table and, making scratches on it. And then that scratches will be filled with copper, and then you have wires. And the same way they will scratch a shape onto it, and those things become transistors. TSMC does that and only that. They don't say how you have to, what kind of transistors you have to use. Well, they do, because the machine has to be capable of manufacturing it. Other than the structural aspects, they do not say how you have to lay out anything, how you have to connect these things together, other than what is necessary for manufacturing it using the machinery.
Fair enough. They may come back and say, look, the design you have sent is not manufacturable. Or
So there is something called a design rule check.
Okay.
These checks, they lay out a certain set of rules which says, hey, you, no matter what, you have to obey these rules of laying out the circuit, because otherwise my machines cannot etch this onto a piece of silicon. So if you don't clear the design rules check, your design will not be manufacturable. So we do a test from our side. They do a test from their side. It's called a dry run. Then we compare results. If we get the same kind of results, and if the basic set of rules for manufacturability are met, then they will manufacture it and give it to you. What they will do is they'll take this circle and make small squares out of it.
I want to just pause at this. You're saying to make small squares out of it. But what I understand is if the front is silicon wafer but the size of my nail, there'll be like a billion of them, or like.
It's just math, right? There's a circle 12 inches in diameter.
Yeah.
So pi r square gives you a certain amount of area. Correct?
Right.
Now, what you're doing is you're inscribing squares in a circle.
Right.
So the corners, you're not going to get, in that circle, the corners are going to get cut off.
Yeah.
Because you're not going to be able to inscribe squares.
Yeah, sure. And then they're like, you're divided into a grid and.
Yes. And every square in that grid becomes a chip.
Right. I'm just saying that when you say etching squares, you seem to be giving a dimension that as if one square is this big, one transistor is this big, but actually
one transistor is a certain size.
Yeah.
Back in the good old days, they are what you would kind of call the nanometer. 180 nanometers corresponded to a transistor dimension of a particular dimension of the transistor being 180 nanometers. But since then, that kind of a thing has lost its correlation, if you will. So a 3 nanometer chip, a 3 nanometer transistor is not exactly, that dimension is not exactly 3 nanometers. It's become a labeling terminology thing. It's becoming a branding thing more than an actual dimension of the transistor, because it's usually slightly bigger or slightly smaller. So that is the nanometer. And what does that?
This is the NM.
This is the NM.
Where
Yes.
Apple says 3 NM chip. Right.
When they say 3 nm, they say that a certain dimension of my transistor corresponds to that size. Only that at 3 nm, that's not necessarily true.
Okay. It's not exactly 3 NM, but
Yes.
I'm guessing that 3 NM is smaller than a 5 mm is smaller than a
Exactly.
18 mm is smaller than a 180 mm.
Exactly.
Okay.
It tells you the number of transistors that you can kind of, crush into a piece, a square, if you will. So at 180 nanometers, if arbitrarily pulling a number here, if you can inscribe 100 transistors in a 1x1 square, at 28 nanometer, you'd be able to do way more than that, because each transistor is smaller, so you can accommodate more.
Yeah.
At 3 nanometers, you can do way more than 28 nanometers for the same reason.
Yeah. This is when people say that when man went to the moon, the computers used were as big as a room, and now you can go to the moon with your cell phone. I mean, with the computing power of your cell phone.
Yes, the 3 nanometer system, the piece of machinery, it's manufactured by a company called ASML, based out of the Netherlands. Each individual unit, each individual machine costs about 250 to 300 million US dollars.
Yeah.
So that's what, $300 is 2,400 crores, give or take, 2,400, 2,500 crores per machine. And it's got a laser, and producing laser light of a certain frequency and wavelength consistently and continuously and deterministically for an extended period of time is a gigantic task by itself. When you take that and basically go have a whole bunch of arrangements of mirrors.
Yeah.
And then you use optics to reduce the size of the wavelength.
Okay. I've lost you at some point.
Yeah. The point here is,
Yeah.
I went that deep
Yeah.
just to show how complicated the machinery is.
Yeah.
Right? So making the machinery,
Real machine that can make 3 nm chips that TSMC will buy, and
it takes apparently several 747s, entire 747s, to carry this one machine from the manufacturing facility to wherever the fabrication plant is.
it's very interesting. We spoke about fabs. We spoke about fabless. We spoke about integrated companies which are both fab and fabless.
Yep.
Now you are talking about a company that makes the specialized machines that fabs use.
Yes.
And we have just spoken about till the wafer is manufactured. I'm guessing there's much more to that before we get our phones in our hand.
Yes. So wafer is manufactured and you have these little squares inscribed in it. Then what happens is the squares get cut and the squares get put into boxes, like you would put a piece of jewelry into, a container, a jewelry box. And these boxes are called packages. So all these, the bare piece of silicon in industry lingo is called a die, D-I-E, silicon die. The silicon die is placed in the package and it has slots for connecting it electrically to the outside world. And the package, you take that thing and connect it to the point in the package, corresponding point in the package. And those are the points that would connect it to the outside world.
Right. But what? So the black thing that we see, which says Intel or Apple M1, that is the package, which is housing the wafer inside.
Yes. What it is called the packaged integrated chip.
Okay.
The silicon die is the integrated chip, and the package is the enclosure holding it, because it needs to sit in a very specific kind of environment, and the package is the one that gives you that environment.
Okay.
And the package connects it to the external world.
But when you use the word OSAT and ATM, what are these words?
Outsourced assembly and testing, OSAT.
Oh, so the assembly of the chip and the testing of the chip. Okay.
And ATMP is assembly, testing, marking, and packaging.
Right.
It's just the functions that those plants do.
Right. So now I have a full picture. So they're design houses, they're fabs, they're packaging plants, OSAT, ATMP, whatever they're called. And there are all these million factories that are supporting these.
There are million subsidiary or indirect players, the component suppliers of the ecosystem, if you will.
Yeah. And while we were talking about this, I figured that you've used 3 company names: ASML, which is a Dutch company, Samsung, which is a Korean company, and TSMC, which is a Taiwanese company. And these 3 are probably one of the largest, or if not the largest companies in their countries, right?
Yes.
Can you explain the Mindgrove products? At what nanometer node they are made at?
Sure. Mindgrove's products are made at 28 nanometer. Okay. Predominantly because we are not building for the state of the art. We are building for the embedded world, which do not need the technological complexity that you would find in a smartphone, which therefore do not necessitate us to do it in 3 nanometers. Frankly, it's cheaper and easier to.
No, explain this to me like I'm really dumb. I understand that 3 nanometer is better than 28 nanometer.
In some certain ways, not in every way.
Okay, let me say that the technology that goes into building 3 nanometer is tougher than the technology that goes into 28 nanometer. But why do I care whether it's 3 nanometer or 28 nanometer?
Why do you care? You open your smartphone and you flick it.
Right.
You see lag. Do you like it or do you don't like it? Do not like it.
I mean, if I flick it and it flicks after 30 seconds, then yeah, that'll...
Right? You open a video and you're looking at doom scrolling Instagram reels.
Right.
And every time you flick, it starts buffering. Would you like it or would you not like it?
No.
You want it fast. That means either you are running it on your data, mobile data, or you're running it on Wi-Fi, right? If you're running on your Wi-Fi, you need your Wi-Fi systems to be capable of pushing more than 100 to 300 Mbps. You need, if you're doing it on data, you need the data, you are pushing 100 to 300 mm. Watching a Netflix video on your phone in full HD or in 4K, you're pushing that much data to your system and from your system.
Okay.
And your telecoms network must be able to handle that kind of data.
Right.
A higher node can help you handle all the speeds necessary to give you that experience, while a lower node cannot, because it will drain your battery significantly faster.
So
But
higher workload, faster, and
But-
lesser battery.
the 3 nanometer, okay, 3 nanometer node will give you much more performance as we think of it, right? The 3 nanometer will give you what is called performance per watt of power consumed. For every 1 watt of power that you consume, how many things can you get done?
Right.
And 3 nanometers is better at that than say 28 nanometers. However, a 3 nanometer node is exponentially more expensive than a 28 nanometer.
Okay, so for embedded systems where Mindgrove chips are used, that much is not needed.
Yes.
Can you explain a little bit more about the Mindgrove products? You make a chip at 28 nanometer, it goes into embedded systems.
Yes, the first product that we've prototyped earlier this year is called SecureIoT, and as the name suggests, it is meant for IoT kind of use cases with a security component on it, some security component on it, because security is an ecosystem thing, and we are effectively doing our part in the hardware. It's intended for stuff like biometric systems, like the fingerprint scanners, or access control systems that you would find all over the place, or your Aadhaar verification stuff. It is intended for consumer appliances. It is intended for industrial control systems as a controller. So all those kinds of use cases where certain functionalities are important, certain voltages are important, certain electrical characteristics are important, and you will not necessarily get those electrical characteristics in the higher nanometers.
Right.
The nanometer is evolved predominantly due to smartphones, because our phones are very, very small. We need space to keep a battery, a board, and a display. So you need to crush in as much as possible of the electronic components into as small a chip as possible, while consuming less power and giving more performance. Pretty complex that. That is the complexity that created all this nanometer thing over the past 10-15 years.
But the sound box, the dabba,
Don't need it.
Yeah,
Don't need it. For those kinds of things, 90 nanometers or 65 nanometers, which came out in like the early 2000s, are way more than sufficient.
right. Because they will also be cheaper then.
Exactly. And you don't need more than that. You can get away with it, you get away with it. So that's what they do. And that's kind of why we chose the 28 nanometer, because we feel it's a Goldilocks node. It's got just the right amount of performance, and it's got just the right amount of optimized power consumption for that technology node, where if we insert our design capabilities into it, where you if you very carefully design your circuitry, you can very quickly get a very compelling product out.
Okay. Okay, so this is the chip that you...
Yes, that is
I saw the news around it was India's first high performance
microcontroller. Yes,
commercial grade.
microcontroller. Yes,
Yeah.
because the processor we use here is the Shakti C-class processor. The Shakti C-class processor was developed in IIT Madras in the RICE lab under the leadership of Professor Kamakoti, then Professor Kamakoti and now Director Kamakoti. And they've done this before. It's not that it has not been done before. It has been done before. It has been done, taped out on 22 nanometers Intel before. So, but it was not commercial grade.
Yes.
It was a technology demonstrator.
What is the difference between a technology demonstrator and a commercial grade?
Prove that you can do something, and prove that you can do something that can be sold. It's the same difference as what you would find in an R&D project and a commercial grade project. Not everything you need to do commercial grade would be quantified as R&D.
You mentioned the Shakti C class processor.
Yeah.
But I've seen that the Secure IoT is referred to as a SoC. So what is an SoC?
System on a chip.
Okay.
Basically, it's a full system on a single piece of silicon.
So it's
Full-
more than just the...
It's more than just the processor. Yes, it's the processor. It's the temporary memories to hold intermediate data, registers and caches. It is the peripheral controllers that interact with other components in the outside world. It is the interconnection system that connects all these components together to allow free flow of data. Yeah, components basically. A Snapdragon is an SoC.
Okay.
Secure IoT is an SoC. right? But there are different kinds of SoCs. In a Snapdragon is way bigger, right? The entirety of the Secure IoT SoC would be like single percentage points of the Snapdragon. So it's like for five
In terms of number of transistors.
in terms of the physical area that the chip takes, the size of the silicon die.
And how big is the actual silicon wafer from Mindgrove? For Secure
That is something that I am not allowed to say.
Okay,
But
done.
I can
won't
tell
ask
you. But I can tell you that after packaging, it's only as big as after packaging, it's only as big as a fingernail.
Nice. So that's your current product. And so what is it going to be moving forward?
The next product is, again, we have a tendency to very literally name our products. It's called Vision SoC. And as the name very hopefully very clearly and by default points out, it is an SoC built for computer vision use cases. So CCTV cameras, infotainment systems, and anything and everything that which can take images from a camera, do some sort of processing on it, and either send it outside for further processing or put it to a display system. Right. So that is the next chip that we are working on, and this is the one for which we have approval from the design linked incentive scheme of the government of India. This is a multi-core. There are Secure IoT is a single core. There is only one Shakti C class processor. This will have at least 4. So the system can have more than a set of processors. So like, for example, a Snapdragon will have 4 processors to run Android, but there will be one very much dedicated to processing videos, right? Encoding and decoding videos. There could be one processor that is dedicated to processing audio. There is a GPU, which is a graphics processing unit, and the graphics processing unit is usually dedicated to putting stuff on display screens, as the process called rendering. So there are several processors in the system. There's not just one. Secure IoT has one, but that's a matter of design. They can have more,
Right.
and Vision SoC will have more.
Okay.
For different purposes strewn around. It's a multi-core, quad core. As we are designing it right now, so the design is not fully frozen. We're still talking to customers, figuring it out, and it will end up being the first of a family of processors. So the way we envision it, Secure IoT and Vision SoC will be a class, not just a chip. We only have one chip of Secure IoT out now, and soon enough we'll have one chip from Vision SOC. But we will continue to make.
Will have variants and further improvements.
Exactly.
Nice. So one is looking at the IoT industry, one is looking at the embedded vision systems industry. Amazing. And of course, your mission is aligned to India's larger semiconductor mission, the ISM mission. And it's interesting to me. Looks like off late, a lot of countries are investing very heavily into, of course, US to the CHIPS Act, and Japan, Germany, India. What is the largest? Why are so many countries so gung ho about being over-invested in semiconductors?
As I said earlier, the semiconductor industry as a whole underpins everything digital. And we are moving everything paperless, right? We get our government services online. We pay online. I literally went to a vegetable vendor, bought carrots, and paid with, and asked him, and gave him cash, and he's like, I don't have change, GPay. Right, so a QR code for 250 grams of carrot. That's where we stand today. That's a great thing. But in order to sustain that, in order to
Great use case is using vision, is using cameras, is using a phone, it's using satellite data,
Yes.
it's using telecom chips.
Yes.
It's like it's using cloud server chips. It's like one use case which covers a huge set of things for whatever, like 30 rupees of carrots.
An event as simple as buying 250 grams of carrot from a vegetable vendor in an open market requires that many chips. Would you, as a state, allow almost all of that to come from outside the country? That is why countries are gung ho, as you put it, to have at least a portion of that built in house. It's the new oil. And for a country like India, the import bills are going to be, if not already, way more than importing oil.
Sure. I read somewhere that already the import of semiconductor components is about 2% of all our imports, or 1.5%, 2% of.
And it's going to go up so quite heavily, because we are trying to do everything digitally. We are paying for everything with a QR code, and that's going to go up. So that alone kind of justifies the need for a local ecosystem. Now, the India semiconductor mission is has other connotations also, right? We are what, 140, 150 crores population, and I read somewhere online that about 60% of our current population is working age, and going to be about 65% in the next over the next 5 years or so. Who's going to give them jobs? If you're importing most of it, who's going to give them jobs? And we are training a lot of engineers, and it's not as if you can give a lot of low end jobs to people to get by. You have really qualified people. That means you have to give jobs, and you have to create and sustain jobs at a level that matches the educational capability of these people.
Does the semiconductor industry create that many skill jobs?
Directly, fabrication plants, no. They'll maybe every fabrication plant can probably, a reasonably sized plant can do about thousands of jobs.
Okay. Oh, but they're all the support industries and the
Exactly.
industries. Okay.
You shouldn't look at a fabrication plant probably as a single as a job creator all on its own. You should look at it as a seed, right? And then you have to bring in the ecosystem around it. If I have a fab, somebody has to supply all these components to the fan. Somebody has to maintain this. Somebody has to be security in that fabrication plant. Somebody has to feed those people, catering. Something as trivial as that, right? Somebody has to provide them drinking water, and somebody has to collect taxes and ensure that these people are paying taxes on time. Government side, somebody has to audit it, right? So if you look at it from that perspective,
Right. Your overall point is that reduce import bill, create an industry which supports a lot of new jobs. And a majority of those new jobs are actually skill jobs which are coordinating to the kind of education that
yes,
Indians are already
the
getting.
world is changing, and we also have to look at how we change our systems to keep pace with the world.
Yeah.
Everybody does GPay, right? I don't even take cash out these days. I don't have cash. I have a credit card, and then and which I barely use, and then I and mostly pay everything on my phone. It's just QR code everywhere. So if that is the way you are going to consume services, the rest of the backend, so-called backend system, must be able to sustain that way of life. How do you go about doing that? How do you generate those jobs? How do you get those people up and running? And IITs, institutions like IITs play a huge role in doing those kinds of things. That's where building gets so important. There is no one company in the world. 60% of our population is 800 million people.
Yeah.
Of that, say let's assume that about what 80 is 10%, 8 million people is 1%. Let's assume 1% of that population graduates college every year and is looking for first time job offers. You have to create 8 million jobs every year.
Desirable jobs.
Yeah, 8 million jobs that is commensurate with the kind of skill that people have.
And the not just the skill, also the expectation and the dreams and the.
Everybody wants to grow. So to that end, forget the semiconductor industry, keep it aside for now. In general, there is no one entity that can create that many jobs. The era of government backed, sarkari naukri is done.
Yeah.
So entrepreneurship is the way to go for that, in my opinion at least.
Makes sense. And just because you mentioned it twice now. So first you mentioned that the IIT Madras RISE Labs,
RISE,
RISC.
Reconfigurable Intelligent Systems Laboratory, Engineering Laboratory.
So the RISE Labs gave birth to the Shakti C-class processor, which is what you built the Mindgrove SecureIoT SoC on.
Yes.
And also now you mentioned that IIT Madras ecosystem is great for building and really support semiconductor ecosystem. So let's just dive into that a bit.
Sure.
Can you tell us what is the Rice Lab? What does it do? How did it start? Broadly.
At the risk of sounding extremely corny, Rice Lab is a lab. It's literally a laboratory where people come. Research work is done on chip design, amongst other things. Because Rice Lab is more of an agglomeration where several professors come together and work on different aspects of the same thing. A lot of students participate in that. They do projects, they do their master's projects, they do their theses, or they do coursework, course projects, BTech projects, that kind of a thing.
Right.
A lot of stuff gets built there. And because of the different fact that different kinds of professors working on different aspects of a larger domain together form the lab, it's not, you're not deep diving into one thing. By the very nature of the lab, you have breadth as well. So there's always an element of coordination, cooperation, which is absolutely necessary if you're doing semiconductors. You can have depth in one thing, but without breadth, without a sufficient knowledge of the other things, you're not going to be able to understand what the other expert is telling you. You won't be able to grasp the significance of what's going on. And the Rice Lab, as it is built, will give you that kind of exposure. And that's very, very valuable when you go into industries like these.
And it's a chip design lab, right?
Yes, amongst other things. They do a lot more than that. So it's not just a design of a chip, right? You have to be able to run software on it. You have to be able to run all these standard open source stuff, like run the GCC compiler or C compiler or Python programs or Rust programs or whatever on this processor, on this design that you're doing. And then you measure this performance like with standardized benchmarks and say. So these people will make an innovation in design, will work on and make an innovation in design. They will demonstrate that, hey, you can take all these standardized stuff that everybody in the world uses, open source stuff, run it on these processors, and look, it's as good as anything else in the world. That's what I meant earlier when I said they have done a technology demonstrator.
Right.
Right. What we do in Mindgrove is take that, yes, this is done. For this application, I will make the experience of you utilizing it much better.
Makes sense. I mean, the role of academia is to invent stuff, discover stuff, put things together, prove that it can work, and then a startup or an industry has to take that and sort of. I love this thing where your office is in the research park, the IIT Madras research park, which supports a lot of startups, and I love this thing where it's next to the IIT Madras campus, and there's a little bridge, and on top of the bridge it says
Industry Academia Bridge.
Industry Academia Bridge, which is
Yes.
cute. I mean, it's quite literal.
Yes.
That you're crossing over from an academic institution to and it's almost like the bridge from the Shakti C-class demonstration tape out to
Mhm.
the SecureIoT chip.
Literally, right? The Industry Academia Bridge starts at the road on the ground,
Yeah.
and connects to the second floor of Research Park's parking lot. That's in a sense what IIT Madras represents and does. That is what a technology demonstrator is. You don't have to start from scratch, ground up, right?
Right.
They give you a baseline showing that, hey, this is possible, and take it all the way up to second floor. From second floor to whichever block your office is in, that's on you. That's the part called commercialization.
Correct. There also IIT Madras support is quite extensive. The incubation cell is there. There are multiple incubation centers now.
Yes. So the way I understand it, IITM IC is an umbrella, and there are several specific incubators. There's one for rural technology, there's one for health technology, there is Pravartak, which is for cyber physical systems, so on and so forth. But there are a lot.
Healthcare, there's a fintech incubator.
Yes, so there's a lot.
You are part of the which incubator?
We are co-incubated, so everybody who works in here is comes under IITM incubation cell, and under that we are co-incubated by IITM Pravartak Technologies Foundation, which is the incubator for cyber physical systems. And well, we're building embedded systems that can go into industrial control systems and robotics and sensors. Can use sensors, actuators, and other such industrial control systems. So we smack bang definition of the domain of that incubator.
Is the acronym for? Oh, I forgot what.
Snacks.
Snacks.
Sensors, networks, actuators, and control system. SNACS.
Yes. I guess, yeah, as you said, you're at the center of it. It actually requires a large number of people to put together something this big. All of them must have a builder's attitude. There has to be an environment.
Rice Lab has about 50, 60 people in it of various, there are project staff, there are contractors, there are project staff, there are project advisors, there are students, there are
Yeah.
BTech, masters, PhD students, a whole bunch of.
You're yourself a PhD student.
Yes.
Why that smile?
Well, I'm also a co-founder, chief architect, wearing multiple hats as a startup founder.
Fair enough.
So I also do a PhD is what I say.
I'm guessing that you'll probably take longer to finish.
Oh yeah. Oh, that is a given. Uh, there was this time when professor called me up and he's like, "Hey, are you planning to finish your PhD or not?"
Who professor?
Professor Kamakoti.
Professor Kamakoti is your
Oh yeah, he's my PhD supervisor, which is fun. Thankful that he's my PhD supervisor because it is because of him that I'm able to run a startup and continue the sweet dream of doing a startup and a PhD at the same time. So he basically gave me the independence to do whatever I want. I'm part time, so I'm not funded. So he was like, so there's no project restrictions and you have to choose your problem within the confines of the project and so on. So you can do whatever you want as long as it is within the ambit of Rice Lab and you justify it to your doctoral committee. So I'm like, okay, that's cool. That allows me to do a lot of esoteric things, which is something that I am trying to do. But yes, it's not all that easy to do. So
fair enough. Just thinking about this thing that you spoke about earlier, so there's a lot of government support. You're a DLI funded startup. You're working in an co-academic setting. How is it like working with institutions like government or semi-government industry? Because I'm guessing it's like, from what I've heard from other entrepreneurs, sometimes it's quite hard. People have mixed opinions because of the scale at which things get done, because of the speed at which things get done. How has your experience been?
Shashwat and I, Shashwat is the CEO and co-founder of Mindgrove. Shashwat and I have a tendency to have three buckets of speed. There is IITM speed, there is startup speed, and then there is government speed. Now, by the metric of government speed, this government, especially our experience working with government for the India Semiconductor mission, has been fantastic. IIT Madras is a huge organization. There's some 18,000 people in it, including all the staff, the residents of the campus, the students, the professors, supplementary, non-teaching staff, and so on. So with that kind of manpower and that level of size of operations, things do slow down. There is a necessary set of checks and balances that have been that
Right.
need to be placed for safe and proper operation of an institution this big. That slows things down, right? Startups don't have that. Startups are famous, or rather in certain cases infamous, for not having control. We prefer to be on the famous part, not the infamous part, just for sake of clarity. So startup is the fastest, and IITM is faster than the government. But the government, if you look at the government, they're hell bent on getting the semiconductor thing done. I mean, it's not just words. The policymakers have been very open about it. They've come to conferences, press interactions, where they've basically openly said that we'll do whatever it takes to ensure that the ecosystem takes hold and becomes self-sustaining. To the point of using those exact words. So kudos to them for that, for thinking like that. And it's not just our experience has been that it's not just words. Our experience, especially interaction with DLI, is that they have been very engaging. They've been very open to feedback, and there were times when we have very vociferously complained, if you will. And our feedback was actually taken very quickly, and they have done everything within their ambit of power to alleviate problems, remove obstacles to pathways, and in general ensure that we are able to They set up an environment for us and get out of the way so that we can go and execute. That's government. That's the slowest of the lot. So you can see just how fast a startup works. And at that speed, a government is not going to be able to match up. If you think IIT Madras with its 20,000 people is going to be, needs its checks and balances, this is government.
Yeah, many more checks and balances.
Right? So it's going to go through layers of approvals before anything gets done. That is the nature of government anywhere in the world.
Yeah.
So the question is, how do you handle it? We have been handling it by being systematic to the point of paranoia. The government will say this is sufficient, but we will look up the law, and it's not just tending to the spirit of the agreement. They say this is absolutely necessary. Anything more than that would be advantageous, but not nearly. And if you have, you can give.
Right, not just to the letter, but to the spirit.
Yes, but we have been doing it to the letter. What that has done.
Isn't the other way around? The letter is the
letter says
about the
the letter says certain things are mandatory.
Yeah.
Statutory, you have to do this. Certain things are good to do, they're optional, right? You want
So you go well beyond that.
We go well beyond that.
Understood.
And we have a team specifically set up to deal with government. It takes a team to deal with government. I mean,
deal with the requirements and
yes,
complex.
They are answerable to they are answerable to parliament. They are answerable to, if they are handling finance, they are answerable to the appropriate financial bodies. They are answerable to the people.
And it is because of the kind of government support and ITM support that you're getting, you're able to move really fast, right? Like, because I remember you saying somewhere that it took 6 months to design the first chip, or was it 1 year to design the first chip?
It took about 8 months ish to execute the design of the first chip.
Right. How much is that in a normal, like say in Qualcomm or some large company?
If you want to build a Snapdragon, something of the scale of a Snapdragon, 5 years. 5 years from scratch, because that's what we did. We have not disclaimer. We have not built anything resembling the levels of sophistication of a Snapdragon. So it's
understood. But what you're saying is that you start from zero, whereas a company like Qualcomm, if it decides to build a new chip, they have some body of work which they're carrying forward.
Yeah, but we spent 1 year, just Shashwat and I spent about a year just figuring out what to build.
Right.
We didn't have any employees. We were just the two of us, and our COO. He became COO later, Uma. We were just sitting and just throwing ideas across to each other, just figuring out what to do. So by the time we got the tools, by the time we got seed funding, by the time we got the market research up and running, we had conversations with customers where we realized if we do this, we have the highest possible probability of getting a product to market fit. Right? We had already done that work beforehand. So execution was 8 months.
Right.
8 months flat.
Got it.
So otherwise,
clear what you wanted to do, you had the exact support, you had the Shakti processor.
And then we had all testing equipment. This is where IIT Madras comes into play. There's an enormous amount of infrastructure available for students and other people to use.
Yeah, through Pravartak also.
To Pravartak. This infrastructure is not cheap.
And by the way, people don't understand it, but for a commercial entity to use it, you must have commercial license of these.
Yes.
You can't just say, I'm a student here, so I'm going to use it.
Yeah. So IIT Madras builds a chip and proves it, right? They can't sell that chip. Because the licenses that they've used to build it are what is called a university license.
Right.
They are meant for prototyping. They are meant for proving concepts.
Sure.
They're not meant to build something to sell.
Sure. But through the incubators, IIT Madras has also negotiated commercial licenses of the same chips.
Yes.
Same tools, so that you can use it.
Yes. Commercial licenses are significantly more expensive than university licenses. Significantly more expensive than university licenses. Especially depending on what kind of tools you want. The more sophisticated your chip, the more sophisticated tooling that is necessary, and the cost growth over there is exponential in relation to levels of sophistication.
Right. This sounds like quite a difficult life. Like you're the architect of the chip yourself. It's not like you're a hands-off engineer. You are the engineer on it. You are a PhD
on paper at least
a part-time PhD student.
Yeah.
And a CTO building a company. So that how do you balance all of this? You're also newly married.
Well, yes.
relatively.
Yes.
So how do you manage all these,
That's a very, that last part is a very dicey question. So I will
Okay,
fill that.
sure. But let's talk about work-life balance, right? Like
Yeah.
how do you figure how to give time to what to prioritize?
Sure. But anyway, I was just joking. I've been married since 2018. My wife is also a PhD student
Oh, wow.
at IIT Madras.
Right.
And she's part of the answer to your question. My wife and my mother, my father is no more. My wife and my mother have given me unconditional support and heavy emphasis on the word unconditional, right? Whatever you go, if I say I have to go for this, regardless of what I've been doing, regardless of the consequence of dropping something in the middle and running away, they'll fix it, they'll figure it out, they'll clean up after me. And I've heard Shashwat saying the same thing. He's got 2 young children.
Yeah.
And
5 and 1.
4 and slightly over 12, bit over somewhere around 15 months.
So a child and a toddler.
Yes, fun. Every parent of young children knows that. And I see all that's happening and I'm like, okay, I'm looking, I don't have any yet, but I'm definitely looking forward to that aspect of life. But family support is foundational. If your family is not supporting you, you cannot do this. It's just impossible to do this. Forget the PhD and startup part. You can't do either one or the other. I've seen enough PhD students who started with me, especially unfortunately female students who got married after joining a PhD, or who came after marriage to join a PhD, and who quit because they've had family problems.
Right, because PhD itself is quite hard.
It's very hard. It is not it's not something that, it's a process of learning how to get insight into a domain.
Right.
It requires patience. It requires you to, what I'd like to say, hold your nerve. You will fail repeatedly. 90%. If you do a PhD for 5 years, for the first 4.5 years, you will have no clue whether you finish your PhD, and you will have no clue what the hell you're doing. The last 6 months, something or the it'll just click, and you'll do something. You'll write your thesis. You'll publish it. You'll get some insight and done. And that's why I said there are people who are working like 3 times as hard as I do and don't have the platform to get that exposure. And that's kind of same kind of chipping in for them.
Yeah, and the subtext here is that you're talking about PhD in one of the most coveted computer science department and labs in the country, right? So it's hard.
It's hard. It's very hard.
Sure. So we spoke about hard, and you said that one of the foundational support is that you have a lot of support from your family.
You also need support from your PhD guide. The PhD guide can make or break your career. So that's why I'm very grateful to Professor Kamakoti. Not for, well, he was the one who made me do the Shakti chip. If you can make it, it will come.
What is this story? Sorry.
I will get to that.
Okay.
But he's allowed me to go explore. And I don't see today, unfortunately, the process of getting a PhD paper or degree ka paper amounts to you publishing something in a particular type of a journal or a conference.
Okay.
And presenting it and getting the approval of
Your doctoral
an
thesis
appropriate
committee.
an appropriate group of people who are empowered to do that.
Sure.
But if you look at what the spirit of what a doctor of philosophy is all about gaining insight. So it's you don't have to figure out the why life is the way it is, right? You don't have to. You just enjoy it. But you're trying to figure out the insight into an engineering problem. You're trying to figure out a particular piece of insight into a domain. And a PhD is one way of doing it. It's not necessarily the, off late I've come to the conclusion that it's not necessarily the only way of doing it. And that particular piece of insight itself comes from what Professor did. So we didn't start off to build out chips. We started out building systems.
Mindgrove started off.
We were like, I will do the hardware. Shashwat will do the hardware, system hardware, PCBs and that kind of a thing. I'll do software. I am a computer scientist. I am not an electronics engineer by training. Excuse me. That's where we started, and we realized that the chips, that this is smack bang middle of pandemic 2020 2021, and we were trying to figure out what to build. We were looking at components that we could take to build. So we realized after a whole bunch of searching and discussions and all of that Shakti was perfectly placed right at the center. It was not too performant. It was not too power. Things that have extreme performance are usually consume a lot of power to do that performance, right? Uh, the ones that are super power efficient didn't have the necessary performance, and you needed something in the middle. And Shakti was sitting in that middle. So we went to professor, who he was not yet director at that point, and we were like, "Sir, when can we get Shakti processor as a chip
For your product that you had imagined.
Exactly?" And just signing a bunch of papers, and then he was like, "It will come when you make it." That single sentence, we were like, "Huh? You don't make a chip just like that. Where's the tools? Where's this? Where's that? Where's this? Where's that?" And it took us a while to get through. I mean, I'm not bombarding those questions, but it took us a while to figure out all those questions.
Yeah.
And we just kept going to him, "Hey, you asked us to say, you are telling us to do the chip. Sir, how can we do this chip without this?" And then he kept answering each and every one of those things. Right?
Interesting.
And his standing was, look, IIT Madras is built as a research organization. It's very, very well set up to prove that a technology exists, to create technology, to engineer and to innovate. It is not set up to commercialize.
Right.
So his standing was, look, we've proved this technology, we showed this is possible, we showed there is no compromise, it is no less performant than any other equivalent in the world. Now you have to take it and do stuff with it.
Fair enough. He
Set
said
it free.
we need a partner on the other side of that bridge. And if none exists, then you just have to be that partner. You have to be.
No. He's like, you also be that partner.
Ah.
You can be one of the people who can take it and do something with it. You do something, whatever you want. I'm not telling you to do this or do that. You do what you think you can do with it, but do it. Because if you don't do it now, we'll make another 300 pieces of this chip.
Yeah.
I will end up framing 2 or 3 and putting it in on the wall in Rice Lab, and the remaining 297 odd chips will sit in cupboard. And whenever some dignitary visits, we'll open, dust it, show it, and put it back in.
I want to just clarify here. You are not the only startup that's come out of Rice Lab, right?
There are multiple startups. They're working on different aspects of the thing.
I'm sure that Professor Kamakoti has said that line, when you make it, to multiple startups or multiple people.
See, making silicon is hard.
Okay.
You have to be a special grade of mental to be able to want to make silicon in today's world. Who else makes silicon? Think about it. Let's see. Nvidia. What's their market cap again?
I don't know. A few $1 trillion.
Largest company in the world.
Yeah.
Done. Who else makes silicon? Apple. Whole different league.
Right.
Who else makes silicon? Intel. Let's forget their recent problems. Intel was
60-70-year-old company. Yeah.
Not just that, they make $60-70 billion in revenue every year,
Right.
and their profit after tax is something like 20-25%. NXP Semiconductors, $14-15 billion in revenue.
Right.
Their R&D spend is $1 billion.
You're basically saying that this is a business where the incumbents are really, really large. They're all billion-trillion-dollar companies. So it's...
And then that creates a question. Why are all silicon making companies that large?
It's fair to say that maybe because it takes that much money to...
I was telling Shashwat, hey, he was like, we were dreaming, right? And we were like, we should do this much in seed, this much in Series A, get that many $1 million in revenue, do IPO and become a unicorn. And I'm like, I'll give you $100 million to spend. How long will you take it? Will it take you to spend? And I was like, 5 minutes flat. That's all. It'll literally take only 5 minutes to spend.
Easy to spend in that.
I just splurge on license fees and do it in 7 nanometer, 100 million, boof, instant.
Understood.
That's the problem with the industry. You have to be very careful when you're designing, and that's why it becomes very hard, because it's very tempting to do it that way. But if you dump in that much capital, you have to have a way of taking all that capital out and making a profit within a reason and breaking even in a reasonable time span, which investors would agree.
Right.
Do I have $100 million to put in of my own money? Nope. Shashwat? Nope. Nobody else. So this is where venture capital, the venture capital industry of today comes into play. It is matured to a point where we can actually go make this kind of a pitch, and then they will not laugh us out just on the sheer principle of
Quite opposite, right? They're saying we believe in you and
Yeah.
let's do it.
Forget selling and all of that. Making a chip is by itself a big deal. Designing it, taking it to production, getting it back and getting it to work is a big deal. What is the risk? The risk is utter and abysmal failure. If it fails, if it completely screws up, and they're also the venture capitalists, from what I've seen, are also the kind of people who look at the positive aspect.
Yeah.
Oh, there's so much risk here, it could fail. Yes, they do look at that, and they do look at aspects for mitigating that kind of risk. And this is something I learned from Rajan Anandan when I was speaking to him, and he asked me this, Shashwat and I, this question: what will happen if this thing succeeds?
It's very interesting.
And then we just told him the process, and then he kept digging, and we kind of arrived at TAM, we get kind of arrived at serviceable available market, potential revenues, and so on. And then he was like, look at the positives, look at the negatives, right? If this kicks off, it's going to be huge. If it doesn't, you're going to be one among the 90% of startups that fail. And that is the kind of risk taking that's necessary for this kind of an ecosystem, unfortunately. Unfortunately. The fortunate part is that there are people who are willing to do that. There are people who are playing in a smaller scale with semiconductor experience who are doing those kinds of things.
I'm just thinking in my mind for somebody in IIT Madras to dream that I'm going to build this, and we say best place to build for a reason, right? Like it requires so much support. It requires something to have happened in an academic setting for you to build on top of. It requires very supportive professors who are building flexible systems, a research park or an incubation center which provides you sort of access to tools, people, gives you that level of validation, maybe just pats you on the back and says, you know what, we'll go through this journey together. And the investor community like Speciale, Peak, and all these other companies which are coming here and saying, you know, we are looking into technology seriously, not as a college project, but something that can move forward. And you mentioned your family, which is giving you a lot of, which is backing you up for everything else in your life, right? It's amazing.
Well, you missed one thing. Failure and the ability to handle failure. What do I mean by that? Let me split it into two parts. The ability to recognize failure. There are people who are extremely stubborn. Stubbornness is not a bad thing. Stubbornness will make you keep trying over and over and over and over again. And the difference between success and failure is one more attempt.
Yeah.
Right? So that stubbornness in that perspective, in that context, is a huge asset. But your greatest asset is also your greatest weakness. You never know when to stop. Some things are not meant to be. You just have to accept that they don't work.
I could call them gritty people also.
Yes, grinders.
Yeah.
The gaming terminology is grinding.
Yeah.
And grinding is good.
Yeah. I mean, Rahul Dravid is a gritty guy.
Yeah, absolutely.
Stubbornly at his crease.
Absolutely. I remember one test match where he took 92 balls to get off the mark.
Yeah.
To score one run. He scored 92, the entire stadium applauded, and he raised his bat as if he scored 400 runs.
The weathered is storm.
The ecosystem is set up for you to fail safely. Are you willing to accept that failure?
Right. Okay, understood.
I was one of those people. I have only had 2 failures in my student life. And that too, it will sound really silly, but in my 8th standard, my maths annual exam paper, I think, I got 59 out of 100. I hadn't got anything under 95 in any course until that point in time.
Right.
I thought I was the world-class failure.
Class 8, it'll feel quite.
Right? When I was doing my master's degree, I had this one course that was a bachelor's course.
Where did you do your master's?
ET Zurich in Switzerland. And their system is such that you are allowed to fail in a course only once. If you fail a course twice, you are debarred from taking that course. The logic there is it is not for you. There's a whole bunch of other things else, so you would take something else. But for me, unfortunately, it was a bachelor prerequisite course and I had to pass it. Right? If I don't pass that course, my master's program will be cancelled and I'll be sent out of Switzerland. I'll be sent back to India. And my father's health was declining at that point. Guess what happened? First time, fail. Okay. And then I retake the exam. And usually what happens is the professors will give you like 8 to 10 problems to solve. You can choose to solve any problem. And then they'll usually come and say, hey, if you solve 3 problems in its entirety, you will get the grade 6. Perfectly in entirety, you'll be able to get a grade 6. And I was like, okay, 6 problems. I can do 2 and I'll be able to pass. Professor comes and like, you need to, this is a very easy paper. And I was like, what? Because it didn't look very easy to me. Computer science student sitting in the department of mathematics writing a theoretical paper. Yeah. And I was a guy who thought, nammalukella maths varadu. No maths. Right? I failed JEE because I failed the math part of it. Not patient with it. I prefer things that I can imagine. And so therefore physics and chemistry is easy. Maths is not. Professor comes and said, easy German, easy paper. You have to get 4 questions to pass. And I was like, fish. I somehow end up attending 4 questions. Then I sit, and then I sit, and then I pray. 9:30 p.m. I get an email saying your grades have been updated. You know what I got?
4. Yes. That was joyful.
Not more, not less. 4. It was 12 years ago. Absolutely irrelevant today. But I failed. Nearly destroyed my career. My father was also one of those over accomplishers. Never failed. And his health was completely declining to the point we were wondering whether he will live for another year or 2. That was the situation. And then I was failing, sitting alone in the middle of Zurich, not knowing what to do, not being able to share it with anybody. And then I passed. Pass. 4. 1 a.m. in the morning India time, I call my mother up and say like I bloody passed. Nice. Right? 10 years hence, you know what that has given me? You came through that.
Yeah.
You came through that, so you can go through this also.
Yeah.
A little bit of farm problems in government bureaucracy and statutory compliances and all that is not going to shake up your world.
Right.
It may cause delays. Yeah, let's roll with it. If it causes a delay, it causes a delay. Worst case scenario, you have to go and make an explanation to your customer.
Yeah. Or you have to just try again.
You have to reschedule your timeline again. It's not, this too shall pass. That's the first thing that I learned. The second thing that I learned is you can try as much as you want. But if external factors require you to take a beating, then there's nothing you can do about it. You can try all you want. But if you have to take a beating, then you have to take a beating. And that is what I mean when I say you have to accept your failures.
Okay. Last question. I promise. What do you find joy in? How do you relax?
These days, I sleep. It's a big deal today.
Yeah.
But otherwise, I am a bit of, I do whatever I want. I do all sorts of things kind of a guy. I cook. I stress clean. My mother is very happy when I do that. I listen to all sorts of music. I watch movies. The more nonsensical the movie, the better. I'm not a big fan of movies that make sense because
Not Inception.
No, not Inception. No Malayalam movies also. They're very good, right? So I generally, they're very serious. They have emotional. You have to invest emotions into you kind of become a part of the character and all that stuff. No, Tamil movies, Telugu movies are my thing. Go beat people up, make a lot of noise. blow up a whole bunch of things, have popcorn and relax.
Yeah.
Uh,
It's interesting. And I guess you watch a lot of cricket also because you mentioned.
IPL these days, yes. I used to. I used to be a very avid follower of cricket, to the tune of watching test matches 5 days, ball by ball. But test matches are not what they used to be. And IPL, I also watch. I watch reviews of IPL or recordings of IPL matches that went to the wire.
Right.
Sometimes it is so dominated by one side that somebody comes and scores 200 runs in an IP, in a 20 over match.
It's
Come
over.
on, man. There's no contest there. Or some bowler comes and takes 6 wickets in like 2 overs, and there's no point in. It's boring. You need that balanced competition where people employ technique, strategy, tactics in a balanced team. That's when I start watching matches these days.
So cricket,
Music,
mindless movies.
mindless. Yes, exercise is not counted as a leisure activity. It's a part and parcel of life.
Yeah. Nice. That's damn cool. Always exciting to talk to you, Sharan.
Likewise.
Very insightful.
Hopefully, you can make me look good on the camera.
Yeah, 100%. Thank you for watching. We were with Sharan at the Center for Innovation. This is the Best Place to Bid podcast. I hope you enjoyed this episode. Do like, share, and subscribe. Thank you, Sharan.
The camera team wanted me to say the same thing, but it's not my channel. I'm not going to do that. But if you do like it, go ahead. These are good people.
Thank you.